In this video, I will show you an example of how to use the Biot-Savart law for finding a B field as created by a line current. So let's suppose we have a Cartesian coordinate system and we have a circular current loop on xy plane, which is the current I with the radius A. And the question is, we want to find the B field along the z-axis. So B field at 0, 0, z. So here we will use Biot-Savart law. Especially in the case of the one-dimensional line current, which can be expressed by this equation. Yeah, if this equation is a little bit different from what you see in the textbook, I uploaded another video, so I will get the link in the description so you can find that video. So to use this formula, we have to identify all the compounds in the right hand side, and then we can do the math. So in the right hand side, mu naught, phi, our physical constant. So we have to find what is r, what is I prime, what is I at that I prime, and what's integral range. So we will find one by one, I prime, and I prime is the position of the source current, and what is the vector current I at an arbitrary source position I prime, and then what is the line integral variable dl prime, and what is the integral range. Okay. And R is very straightforward. It's giving the question. We want to find the B field along the z-axis, so it should be 0, 0, z. And I prime is you can choose any arbitrary point along on the source current. So this position vector can be R prime. And if you see this in the top view, we have a circular current loop, and we chose arbitrary point as our prime source point, and radius is A. And this source point can be expressed easily using the angle P prime. So R prime will become, the radius is A, so I prime is always on the xy plane, so it's z component equals 0. And the third component I prime means what is the other vector of the current at that I prime. So if you draw a vector of the current I, it will look like this. Okay, and in the Cartesian coordinate system, you can decompose this xy component of this I vector, this x component and y component, and here's the angle P prime. And again, current is always the has no z component, z direction, so it's z component equals 0. And we need to do the line integral, and line integral will be done along the z-axis, along the blue curve. And in the cylindrical coordinate system, it becomes because the small line element here, dl prime, will be longer when we have a large radius a. So it's proportional to a, so it's a times dp prime. So now we found all the components, so you can plug in these to the blue Biot-Savart law equation and just do the math. So I will show you that. There are a lot of r minus r prime, so let's find r minus r prime first. Then we can plug in these to the Biot-Savart question. And r equals 0, 0, z. We need the range, and we need a long line, and dl is a dp prime, and the numerator is denominator is the magnitude of r minus r prime, and q is q. So it's a little bit long, but we can do step by step. So if you let's take a look at the cross product first. So if you want to find the cross product A and B, you can use the determinant of the 3x3 matrix. This is the vector I at r prime, and we can write down r minus r prime here. And this will be x component will be this one minus this. Component, z component. So if you plug in this, then we have the a from the adp prime out of the integral. So we have 4 pi not a. Sine square plus cosine square equals 1, and denominator so we have a vector inside the integral, so it means the integral we have to do the 3 integrals for x component and y component and z component separately. And if you look at this p prime, this is the integral over p prime, and we have only p prime in the cosine and sine. But as you know, if you do the integral of the cosine from 0 to 2 pi, or sine 0 to 2 pi, it becomes 0. So actually the B field has 0 x component and 0 y component, and only non-zero value in the z component. And if we do the integral of z component, these are just constants, so IA times 2 pi. And this is only z component, so it's only z hat as a direction. Okay.